Good afternoon, everyone. Welcome to the second afternoon session of Day 2 of Quantum Eastern Europe. My name is András Pályi. I'm a theoretical physicist from Budapest, and I will moderate this session. The title of the session is Funding and National Initiatives, and in this session we have 3 talks and a panel discussion with the 3 speakers. The first talk is given by Tommaso Calarco. As many of you probably know, Tommaso has been a central figure in creating and running the Quantum Flagship program in the European Union and in building the quantum science and technology ecosystem in Europe. In his academic life, Tommaso is the director of the Institute of Quantum Control within the Peter Grünberg Institute in Jülich, Germany. And his talk is entitled Quantum Technologies in Europe, from a Flagship to a Fleet. Tommaso, thank you for being here and looking forward to your talk.
Thank you very much for inviting me here, to the organizers, and thanks to the attendees for joining us. And now I am sharing my screen, and I would like to start by telling you a little bit what is the current status of the flagship, and especially what it will take to go from a flagship to a fleet. And here I see already that my first slide has the wrong title, but never mind. And I want to go to just in a few words, of course, summarize what is the Quantum Flagship. So it's a Europe-wide initiative involving the Commission and Member States together. We will come back to that in a moment, which starts from European leadership and excellence on the science side to consolidate that and to start bringing this to the market. So being competitive in terms of leadership of European industry as well, in order to attract investment and talent to Europe and develop a series of applications. So those are the applications which you are aware of. And those are, for instance, the application pillars in communication, simulation, sensing, metrology, computing, and basic science. And each of those has its own goals. And well, we have next week, and in exactly 1 week, we have in Paris the final review meeting of the first ramp-up phase of the flagship, the first 3 years in which these about 20 projects are going to be reviewed, and we start into the second phase. So what is important here in the title, we allude to the fact that we are moving from a flagship to a fleet. And what does that mean? It means that from these application areas, we want to really go into the implementation, and the application areas of the flagship are funded within the Horizon Europe framework program for research and innovation. And as you see here, they are listed here. And in the new version of our strategic research agenda, we sort of consider basic science as an underlying resource for all of these fields, together, a scientific resource, together with technological resources such as engineering and control and software and theory development, also as well as with the transversal dimension of education and training, which I will also come back to in a minute. But this is in Horizon Europe, and in Digital Europe, the program for really digital society in our continent, we are deploying 2 infrastructures, EuroQCI, the European Quantum Communication Infrastructure, and EuroQCS, the European Quantum Computing and Simulation Infrastructure, under the joint undertaking for high-performance computing, EuroHPC. So here are some of the goals summarized from our strategic agenda from the flagship. So sensing and metrology, I mentioned them first because it is very sort of diverse. There are different applications from clock synchronization, positioning, temperature measurement, pressure, spectroscopy, measurement of gravitational fields, microscopy, magnetic fields, and so on. So the idea here is to continue the development and deployment of these technologies, not only on the scientific side, but also bringing them, closer to market, and some of those already to market. Some of these applications are the ones which also our industry believes are the most mature for market deployment across the whole of Europe. So this is not just one big project, but there is a range of different projects which are addressing different application areas. So if we now consider computing is sort of kind of the longest term undertaking here. The idea is in the long term to connect quantum computers via quantum networks to have perhaps distributed computing, but also to develop new quantum software on the existing different platforms from quantum hardware, developing also the different platforms. You see here on the lower right that there are different levels of maturity of different kinds of technologies, and combining them with high-performance computing. And we will come back to that when we speak a little bit about the infrastructure dimension. Now, this is the computing, so general purpose computing, as you know, and then there is also the simulation, which in our research agenda is distinct from that in terms of special purpose quantum computers, if you wish, which find application in different areas from chemistry, nuclear physics, material sciences, fluid mechanics, optimization, routing, and so on. So here the goals is really, since this is already closer to application, so here again the point is important integration to end users, both in science and in industry, in order to develop programmable quantum simulators, which can be applied in areas such as chemistry, material science, and others. So, well, where do we stand? Well, we know that, some companies such as IBM are already selling quantum computers. So they are commercially available, not with a very high number of qubits, but some other companies, again, in the US, you may start wondering, well, like Google, they created some very powerful chips, and this is the chip on which Google realized for the first time the so-called quantum supremacy, namely an experiment, as many of you know, in which this chip has outperformed a supercomputer on a certain computational task, which was really completely artificial. It is the sampling of a random distribution of unitary matrices, so it is not something which has a practical use. So you could say this is really a fundamental sciences experiment, but this opens the way to really realizing and seeing that quantum computers can come to reality. And by now, you might have started wondering, and certainly our decision makers in Europe are starting wondering, okay, but what about Europe? Because this is all American, US companies. But now, the first ramp-up phase of the flagship has already led to several startups. And in the program, we had a talk by IQM today, and here, and there are others such as AQT IQM is in Finland, dealing with superconducting qubits, AQT, Alpine Quantum Technologies, in Austria, dealing with ion trap. And this is a company, Pascal, which is a spin-off. I'm presenting here for two reasons. One, because it is a spin-off of the quantum simulation project in which I am myself involved with Rydberg Atoms, and it is localized in Paris. But also the second reason is that this is the first time in history that it was possible to get a discount on a quantum computer, in the sense that we were creating the first pilot project for the quantum computing simulation infrastructure I will mention in a moment, and I was able to convince the CEO of Pascal to sell me 2 quantum simulators for the price of 1. And so we will have one located in Paris, near Paris, in the Plateau d'Orsay at CEA, and one in Jülich, in our national lab here in Germany. And importantly, this is an infrastructure. So this is for creating access to everybody, all users from science and industry, to really deploy these technologies and being able to develop new applications. So this is indeed the concept of this quantum computing and simulation infrastructure, EuroQCS, which I believe also Yasser will touch upon afterwards in his presentation. And the idea here is that, we are combining existing high-performance computers with what we could call the next generation high-performance computers, which will be, hopefully, if we are successful, and we have always to say if, because it is still a long way, and we are far from being sure that we can master all the engineering challenges, but provided that we succeed, we want to start already with the first existing quantum processors and combining them in the HPC infrastructure as testbeds for both for people who develop hardware in different kinds of platforms, the ones which I mentioned before, ion traps, superconducting qubits, neutral atoms, but also very prominent and important photonic qubits, spin qubits, semiconductor qubits, and really to develop in combination as co-processors to high-performance computers, but also as standalone machines connected via cloud in a second stage to develop a database of applications which should be really validated and verified for providing quantum advantage for actual real applications. So this is a point which I would like to underscore very much. This is not just taking some few quantum computers from some few startups and putting them into some big fat places in which there is a big fat supercomputer. No, this is just the first step. Also in the intentions and in the implementation of the European Commission, this is the first step, starting with quantum computers as co-processors, but then moving to a broader, to a more distributed network of quantum computers, which should be accessible as a cloud service. You know, if you wish, creating something which could be the European analog of what we see in the US, for instance, with Amazon Bracket. So that's the idea that we have here. And this is for quantum computing and simulation. Now, as many of you know, quantum communication is indeed the most advanced commercially already of the quantum technologies, in the sense that we already can purchase by several companies in Europe, both in geographic Europe, such as Switzerland, where very prominently the first startup in this context was founded, but also in, let's say, formal Europe, in the European Union. There is a growing number of startups growing. I will show an example afterwards, which really sell commercial devices for quantum cryptography, quantum key distribution. But of course, in the vision of our strategic research agenda, there is also the idea to extend this beyond just quantum key distribution and beyond the existing applications of quantum random number generation, but moving towards really secure computing in the cloud, also connecting quantum computers with the secure quantum communication channels in what we could call a future quantum internet, as well as enabling the deployment of such quantum channels for other tasks, such as, for instance, networking, sensors, and clocks for time distribution and secure certification, for instance, of time. So here, the challenges which are ahead of us are, of course, those of scalability, increasing the range of such quantum communications. At the moment, we have a point-to-point quantum communication up to a range of a few hundred kilometers, but really we want to achieve a European scale. And so for this, we need quantum repeaters. And of course, this is something which is being developed again in our flagship and several research projects, which are providing the technology then for the deployment. And for the deployment, what we need is a strong reliability and robustness of these devices in order to reach at least 800 kilometers with telecom fibers in the real world, and with quantum networks with nodes which have processing power which is needed for this quantum repeater function of at least 20 qubits. So those are the goals, as you see here, which we have in our strategic research agenda. I should mention, now that I have showed you a little bit of a summary of different research areas in the strategic research agenda, that last week, in the last meeting of the Strategic Advisory Board of the Quantum Flagship, we discussed with the Commission the need to update now the research agenda. And actually, it will not just be a research agenda, but it will become a research and innovation agenda, not only encompassing the strategy for science, but also for industry. And this is a process that we are going to start soon over the summer. And we aim at completing this by the end of the year, because this is needed by the Commission for setting up the next calls. And so this is something in which the whole community and all of you who are here today will be asked to participate and to provide input as much as we have done in the past. And this is very relevant. And I'm very happy that, in the past it was like we wrote this research agenda and we proposed it to the European Commission. But now really what happens is that the Commission is asking actively us to provide this to them. And they take this really to write the calls in the flagship. So the upcoming calls are going to be determined by a lot of expertise that we collect across Europe, including the expertise coming from the community. So I really encourage you to participate in this process. Now, of course, when we speak about deployment, as we said before, we see that in the world, for instance, the Chinese government has strongly funded this. So there is a series of connected quantum segments between Beijing and Shanghai since a couple of years. There is also quantum communication satellites in orbit. Also, the US, as we know, have since a certain time a quantum satellite in orbit, but this is a dark program, so this is why we don't get a lot of publicity on that. But this was also among the motivations why we don't want just to stay there and observe what is happening, but all 27 European member states, including all member states of Eastern Europe, which are particularly relevant for this particular conference, Quantum Eastern Europe. So we can say that the quantum side of Europe, which is on the east, really has joined this undertaking of a European quantum communication infrastructure, in which we are connecting, starting from all the capital cities and then many cities in Europe, via secure quantum communication channels with a range of applications, integrating both terrestrial and satellite channels in order to bring quantum cryptography and quantum security into critical communication systems. And for a lot of applications, again, from protection of data in networks to synchronization of clocks, as I mentioned before, and others, in order to create a backbone for the future quantum internet. So in a way, the internet consists of computers and communication channels already now on the classical level, and we are developing quantum computers and quantum communication channels, and the long-term vision is, of course, to combine those into a real quantum internet. And actually, I had the honor of presenting at the G20 last summer the first instance of a demonstration of this quantum communication infrastructure between 3 member states of the European Union, Croatia, Slovenia, and Italy. This was made easier, of course, by the fact that this was in Trieste, where those other 2 member states are not far away from, but still it was the first time that this was performed, I think, worldwide between 3 different states. And here I have a picture also of the startup I mentioned before. It's not just the important, the prominent market leaders, which we see from, for instance, like ID Quantique from Switzerland, but we have been doing this in Italy. And this was an Italian startup, Quantum Communication Italy, QTI. And there are other startups, by the way. We saw it at the Quantum Technology Fair in Munich last week. There are other startups in Italy and in many other countries which are deploying and selling this kind of equipment. So essentially, those are the areas that where we are providing technology which goes into infrastructure. But in our agenda, as I mentioned before, we also have the aspect of science and technological resources. Scientific resources are more on the foundational side, like quantum information theory, even the theory of quantum foundations, which can and will give rise to new ideas and new possibilities for quantum technologies, but also the understanding of such fundamental phenomena as decoherence, which play an important and essential role in terms of being the need of overcoming them in the deployment of quantum technologies. When we speak about technological resources, there are both enabling technologies, which is like chip production for quantum computers or quantum communication devices, all the controls theory, the software development of algorithms, more in general, the theory of such devices, as well as more on an engineering practical point of view, manufacturing and packaging. All of these dimensions are coming together in what we now, in the current version of the research agenda, we are defining as scientific and technological resources. Of course, what we need is competence. We need people who are able to, really engage also in the many projects, both at industrial and academic side, which are being enabled by these big programs. By the way, I forgot to mention that when we started, the flagship was supposed to be 1 billion euros over 10 years, and we thought so, but we were wrong. In the meantime, it is 7 billion euros over 10 years between Commission, which is in excess of 2 billion, and member states, which are also investing very substantially. So we need people to be able to perform this research and development. And so here the role of education is very important. And we have also a coordination action on this, which has started last year, and another one which is starting, in which education is an important dimension for the next phase of the flagship, the coordination action QCATS, which follows the current one, QFlag, which has just finished like 5 days ago. Then when we discuss about infrastructures, it's about, bringing, again, from research to the market. And so there are a lot of other aspects which are very important also at the European level, like protecting intellectual property, finding some common standards, which also can be valid worldwide, and also, lowering cost of producing this kind of technologies. So this is the content of the aspect and also the course that we have on the aspect of innovation infrastructure, which we are also pursuing within the flagship. Industry plays a very important role here. This is why from the Quantum Community Network, one of the 3 governing bodies of the flagship, which together with Yasser, I am chairing, we have taken the initiative 1.5 years ago to found the European Quantum Industry Consortium. And I am very happy that now this is growing to with a very much stronger rate of growth, and actually it is now comparable or almost bigger than the counterpart in the US, the Quantum Economy Development Consortium, QEDC. So here is just a summary of the different member states which are involved and represented there, and you see also that there is not yet so big but growing component also from Eastern Europe. Now, I spoke in the beginning, and here I have a couple concluding slides about the fleet. So what do we mean by quantum fleet? So here, summarizing what we just said, we have in the center of the flagship, we have our strategic research agenda with those 5 fields that we mentioned before, which are being funded by the framework program Horizon Europe. And they are trying to reach those moon landings, such as building the first quantum computer in Europe, creating a first pan-European secure network, and so on. But there are other programs of the European Commission which are relevant here. For instance, the space program, which is relevant both for the satellite dimension of the European quantum communication infrastructure, but also for instance, something such as satellite navigation. And the European Space Agency, thankfully, is getting engaged in this. On the other hand, also the new program Digital Europe, in terms of infrastructure, both for quantum computing and simulation and for quantum communication, but also with the new programs for digital skills. There is a call open for teaching master's programs for different digital technologies, and there is a consortium being prepared for quantum technologies. And also in that, the high-performance computing joint undertaking EuroHPC is located. So this is also something which is beyond just the research framework program, which is funding quantum technologies, also in a way relieving the pressure, because the more downstream, the more really application side is coming into that. Of course, there is the aspect of training and education of early career investigators, as we mentioned before, and the role of member states, all of them actually, is a very, very prominent one. Quantera is to date the largest ERANET, which is encompassing really all funding organizations of all member states and several associated states. There are other important organizations at member states level, for instance, EUROMET, the Association of Metrology Organizations in Europe, as well as the European Space Agency, as we already mentioned. And around the corner, there is the dimension of international cooperation, which is being pursued with different extra-European states. As we speak now, a meeting is going on in Washington, D.C. at the White House with several member states in order to explore possibilities for international cooperation, and we are trying to push this also on the European side. I will have a meeting in the White House also around the end of the month to discuss also this. So you see, what do we mean when we say that we are moving towards a fleet? We mean that really we are encompassing the whole spectrum, from the research, like the European Research Council and the Quantum Flagship, which is more on the fundamental side, the basic research and the technological research side, to supply technology to the other programs, towards the program Digital Europe, towards the right of this transparency, in which we develop digital skills in terms of training, for instance, master programs, in terms of quantum technologies, but also with the infrastructures that I mentioned before, and also a new possibility to enhance, to make easier the establishment of a real European also economic ecosystems involving startups, the Quantum Technology Fund, which is involving the European Investment Bank, the European Investment Fund, and the European Innovation Council, which is being put together in order really to also help the bridge, let's say, the so-called valley of death between the lab and the market, and supporting with public investment those startups. So this is the summary of the whole quantum fleet. At the core, we have the Quantum Flagship with the Research and Framework Innovation Program. We also have the Quantum Fund supporting creation of new companies. We have the infrastructure dimension, both on the computing and on the communication side. And we have, very importantly, both the member state programs in Europe, both in Western and in Eastern Europe, as well as the association, the consortium of national funding agencies, Quantera. So this is something which will bring us towards the next future after the flagship. And indeed, let me conclude by saying that in the last meeting of the Strategic Advisory Board last week, we decided, also with the full agreement by the Commission, that now a much stronger integration has to be sought between the national programs, the national quantum initiatives, and the European dimension, so that we can create the basis for a future partnership which can lead Europe in terms of development of quantum technologies beyond Horizon Europe, so beyond 2027, because of course, as we know, it is a long path that we have ahead of us. We already achieved some very remarkable results, and we will be able to move forward only if all of Europe is involved. And this is why I'm very happy to have the opportunity to talk to you today. And now, of course, I am open for any questions that there might be.
Thank you very much, Tommaso, for this informative talk. We have one question in the Q&A from Oksana Mishina. What is the state of Europe's SuperQ quantum computer project?
So there, I am not sure which specific project you're mentioning. So there are several quantum computing projects being funded and now being concluded in the ramp-up phase of the flagship. One is called Action, which is based on ions. Another one is called Open SuperQ. Maybe this is the one you mentioned. Open SuperQ with superconducting qubits. So they have achieved all the milestones that they set out. So they have, in the case of ions, a few tenths of qubits operational now. And in the case of superconducting qubits, as we know, we are not so advanced like those big companies in the US. So it's on the order of between 10 and 20 qubits for that. And the current status is that this is going to be made available in the context, in the next iterations of the European Quantum Computing and Simulation Infrastructure. So I hope that answers that question.
Thank you very much. There's a second question, which is a bit focusing on the widening countries, but let me read it and discuss it anyway. So what opportunities exist for a startup from Eastern Europe without academic connection or connection to large companies to access its own EU funding? That's the question.
So, at the moment, we are creating this European Quantum Technology Fund exactly to enhance those opportunities. And this is something which we expect should be operational on the time scale of order 1 year, so to say. And in the meantime, it's very important, I think, the networking. So my advice would be, it is a very low threshold entrance fee for the Quantum Industry Consortium QuIC. So for SMEs, it is really a couple €100. Which enables to access all the network of small and large companies, to develop connections, to participate in defining the priorities, and to get all information about opportunities, and also to get in touch with VC, venture capitalists, and other kinds of investors, which can support your company. So this is one of the reasons why we created that, which has also a specific SME chapter devoted to the sort of development and protection of the interests of SMEs.
Thank you very much. We will have more opportunity to ask questions from Tommaso in the panel discussion. But for now, thank you very much for the nice talk and for these answers. And let's move on to the second talk of the session. So the second talk is going to show a case study on a national initiative in quantum science and technology, focusing on the current state of affairs in Hungary. It is given by Edina Németh. Edina, can you please, switch on the camera? So it's given by Edina Németh, who is a funding expert and the national contact point for Horizon Europe, Digital Europe, and the European Innovation Council, working at the National Research, Development, and Innovation Office of Hungary. Edina, thank you very much for accepting the invitation, and we are looking forward to your talk. Please unmute, please.
Okay, so as András mentioned, I am representing the National Research, Development and Innovation Office in Hungary, which is the governmental body responsible for funding programs in research, technological development and innovation in Hungary. We have responsibility for both national programs as well as European programs such as Horizon Europe and multiple others. And in Hungary, it's been while since we have been supporting quantum technologies, and we have a range of programs in this area. Some of them are targeted, but others are open thematically, yet quite popular among researchers in this area. So I just mentioned a few of these programs in my slide. Obviously, the one highlighted in yellow is the most prominent one, because these programs have really started quite early in Hungary compared to other European countries, and they directly aim at supporting quantum technology research as well as academic industry collaboration. So I'll have a few more detailed slides about those in a minute. In addition to these, we have multiple initiatives that aim to position Hungarian researchers and Hungarian research activities internationally. I'll mention a few of these. Of course, we do support participation in Horizon Europe, and some of our actors have been quite successful in being included in both long-term research programs within the European Innovation Council's Pathfinder program, as well as targeted research programs in other clusters of Horizon Europe, in cluster for digital industry and space, for example, recently. In addition, we have some other transnational initiatives that we participate in. We dedicate significant funding to Quantera, which issues transnational calls biannually to bring together European researchers and ensure that there's research collaboration across multiple countries. And Hungarian researchers have been quite successful over the years. Perhaps some of the first calls we had 3-4 participants, but in the most recent calls, we are funding 6 different consortia in this area with Hungarian participants. We're also actively engaged in the EuroQCI. This program is currently under evaluation, but there's also a Hungarian proposal involved in this program. What we are doing nationally, we have multiple open schemes that are quite popular among quantum technology researchers. We have researcher-initiated thematic applications where the researchers submit their ideas bottom-up. We have a research excellence program for some of the top researchers. We also have a very prestigious grant organized not by our organization, but by the Hungarian Academy of Sciences called Momentum. And there we have multiple research groups across several institutions that are engaged in quantum technology research. Our organization, furthermore, has calls directly targeting young researchers, and in fact, it's been quite popular to apply in the area of quantum technologies. And we have academic industry collaboration programs as well. So next, I will move to our national quantum technology programs. So within, once the quantum flagship program started, it's around the same time that Hungary was also considering a targeted program in this area. So we were among the first countries who did have a dedicated program. This was in 2017 that we launched it. And it was around the same time we launched multiple targeted large programs within Hungary. Going on to quantum, so basically the title of this program was Producing and Sharing Quantum Bits and Building Quantum Information Networks. And in fact, this program ended last year, but it really did have a structuring effect on the Hungarian quantum technologies communities and really brought together researchers, a critical mass of researchers, as well as industrial partners in this one consortium that lasted for several years, and further information is available in the link on the slide about this. Now, more recently, last year, Hungary launched a new quantum technology national laboratory program. This will last until 2025, and here the research is aimed at 3 main research fields. One of them, in alignment with the EuroQCI initiative, is the realization of a quantum communication network. We also have a research field called Building Blocks of Quantum Information, as well as quantum computation and simulating quantum systems. Multiple sub-projects are running under these three main fields, and I also included a link here that explains what this national laboratory is doing day to day, also available in English. Okay, next. I want to mention that we're also directly involved in Quantera, and as Tommaso mentioned in his presentation, that there needs to be a focus on more alignment with national programs and EU programs. I want to take the moment to advertise that we do have a publication produced by Quantera, which describe basically the quantum technologies and public policies in Europe in this area, including the Hungarian, and an updated version of this document is coming quite soon, which will include a description of the new Hungarian program as well. Okay, so very briefly, this is a quick summary of what we are doing in Hungary in this area, but I can say it's highly prioritized. It's been highly prioritized, and we're actively aiming to bring in young researchers to keep Hungary actively involved in the European and international field in this area. So thank you.
Thank you very much, Edina, for this nice summary. We don't have any direct questions to you in the chat, but I might have one, especially in regard of the previous session. I'm not sure whether you could attend it or not. So it was about V4 collaboration, so Visegrad 4 countries collaboration, where for those of us who don't know what V4 is, so these are the four countries: Poland, Czech Republic, Slovakia, and Hungary. And so the question to you is that, I mean, in that session, I was feeling some kind of urge to do something together in the quantum science and technology scene. So do you have any ideas, thoughts about how to approach that? So if the researchers would like to interact within these 4 countries, are there already like tools for doing that, like funding tools, or is there any political, action taking place?
Okay, currently it's a highly prioritized collaboration between the V4 countries. So politically, there's really a strong will to do it. I think if we want to suggest quantum technologies as an area where these 4 countries can really collaborate more closely, I think there would be quite a bit of openness towards this, because we're really looking for the fields where this makes sense. And I think our countries have a tradition of a strong academic research background in this area, and it would be very good to really boost this collaboration in this area. I think Quantera has done a lot so that our funding agencies between these countries are discussing on a regular basis, meeting on a regular basis. So it's a good start, I would say.
Mm-hmm. Thank you very much. We are a bit ahead of time, but that's okay. Thank you, Edina, for the nice talk. And let's move on to the third talk of the session. This is going to be given by Yasser Omar, an associate professor at the University of Lisbon in Portugal. And the title is Widening the Participation in the Quantum Flagship. Yasser, thank you for accepting the invitation and looking forward to your talk.
Thank you. Thank you very much for the invitation, and thanks for the introduction, Andras. So let me share the screen. I think this is it. Can you see it?
Yes, it works.
Great. Thank you very much. So first of all, congratulations on this great initiative and bringing colleagues from all these countries in Eastern Europe, from all the north to the south, to raise quantum awareness. I think this is a great and very important initiative. So congratulations to the organizers. I wanted to tell you about the issue of the participation of widening countries in the quantum flagship. So we've heard about the program. I think you're familiar with it now. Let me just define what widening countries are. These are 15 countries out of the 27 EU member states. So let me enumerate them: Bulgaria, Croatia, Cyprus, Czechia, Estonia, Greece, Hungary, Latvia, Lithuania, Malta, Poland, Portugal, Romania, Slovakia, and Slovenia, and any other associated countries, including some who are also represented in this meeting, that have equivalent characteristics in terms of their research and innovation performance. So this corresponds, in fact, in terms of EU member states, to the majority of the countries. And so how has the flagship addressed this issue? So first, as Tommaso mentioned before, one of the governance bodies of the Quantum Flagship program is the Quantum Community Network, where we have representatives from the quantum scientific community from all EU member states, as well as associated countries, namely Switzerland, Israel, Norway, Turkey, and the UK. And so we have these 32 countries. And so this was actually non-trivial to create, and I believe we can say, even though of course our opinion here may be a bit biased, that this has been a very successful network that has contributed to the development of the flagship. And so this is very important because all these countries, all these 32 countries have a voice, and in particular, all 15 widening countries have a voice. And I'm insisting on this because at the beginning, there was a debate and the intention to create a network where not all countries would be represented. That's why I'm insisting on this. It may seem a bit obvious today, but in fact, it was not at the initial stage. So I think this is something very nice about the Quantum Flagship that can also be helpful for other programs. But of course, today here we are focused on quantum technologies in Europe. And so what I have here are some statistics of the results of the first call of projects of the Quantum Flagship. So this was a call that happened in early 2018, and in fact these projects just ended. As Tommaso alluded, the final cluster review will take place in a week's time. But these are the data we have so far, and this study was developed by a bunch of colleagues from our Quantum Community Network, and in particular these statistics I want to credit Tony Apollaro from Malta, who did this study. Okay, and so here in our program, in the flagship, as represented by the Quantum Community Network, we have 16 countries, 27 plus those associate countries, and Turkey counts as a widening associate country. So we have 16 non-widening countries, 16 widening countries, and then in terms of the countries that got projects that were funded in this ramp-up phase of the flagship, we only had 20 countries funded. So the issue of inclusiveness is actually wider than the issue of the participation of widening countries, and this is something we should not forget. But out of these 20 countries that were funded, let's call it this way, 14 were non-widening countries, and only 6 out of the 15 widening countries got funding from this program. These calls. And in particular, out of the 128 million euro that were available in this call, the widening countries only managed to capture about 3 million, which corresponds to about 2.5 of the funding. So you see the majority of the EU countries are getting about 2.5% of the funding. And this is a huge issue of imbalance and fairness, but also of sustainability, because the flagship program is essentially funded by the Commission, which itself is funded by the member states. So we still don't have results for the most recent calls of the flagship. So we are very curious to see what the performance there was in terms of inclusiveness, and in particular of the participation of widening countries. But we have some good news from the latest call of Quantera, the ERANET on quantum technologies that was mentioned in the previous presentations. And so the latest call, the 2021 call, there were 85% of the projects that involved widening countries in their consortia. And you have some statistics there, which you can find on this map, which you can find in the quantera.eu website. So this is very nice, but I think we should be satisfied with this, but I think we need more. And a very important point, at least in my individual opinion, is that the good participation of widening countries in funded projects in the Quantera program should not be an excuse not to have them funded in the Commission fully funded by the Commission projects. But so let me go back to my previous slide, because as I mentioned, I think this is a sustainability issue, and so see what are the challenges at stake and how they are being addressed. So I think the first is the one I mentioned. There's this huge imbalance in the distribution of researchers, and this poses a challenge for everybody, of course, for the countries that were not funded, including countries that are not widening countries. I want to insist on this. But in particular for the widening countries, where the effort to contribute to this funding, to this research program, is sometimes larger. And so this is a sustainability issue for everybody in Europe, for all the countries, because maybe some governments start decoupling from this and saying, oh, why are we putting money in the pot if we don't get it back, and we are funding the research in richer countries? And of course, this is unfair, and this is something that needs to be addressed. The second point is, I think, the performance of Europe, because there's great scientific capacity in all countries, as this conference showed yesterday and today. So congratulations. I think this is, again, very important effort that you're developing. And this excellence is not being exploited, is being exploited very unevenly. And so in the end, this is bad for Europe. There's very good capacity and expertise that the European Union, or Europe in general with its associate countries, European Union with its associate countries, are not benefiting from. And thirdly, this is a vicious circle that needs to be broken, right? Because these programs evolve, the same organizations, the same countries get more funding. This allows them to also leverage more national funding, and they keep growing, and the opposite happens in other countries. So it's very important to break these vicious circles to address these challenges. So what solutions have been found so far? So first was the very important awareness since the beginning that from the EU perspective, this is a EU27 problem. This is not just a problem of widening countries. The fact that few widening countries are capturing funding, are getting involved in the consortia, in the networks, research networks, this is not the problem only of the widening countries. This is a problem for the whole of the European Union and the programs by the Commission. And so in our Quantum Community Network, we have been addressing it as such. I think that was a very important aspect. The second point was that in our discussions in the Quantum Community Network, we always said excellence is paramount. Okay, so we've so far never considered having solutions with some quotas to guarantee the participation of some countries, etc. So excellence should be the main criteria in these solutions. And we actually achieved something non-trivial, which was to get support from the Commission that in the most recent flagship calls in the Horizon Europe program, so these were calls that closed, first set of calls closed in last October, and the other set of calls closed this January. And in all these calls in the Horizon Europe program devoted to quantum technologies, the Commission, after discussing with the Quantum Community Network and understanding the challenges that this was posing to these different member states and to the program as a whole in Europe, they were sensitive. And I think this was a unique solution. No other call, to the best of our knowledge, had this sentence that was added there upon the suggestion of our work group in the Quantum Community Network. And the call says that these proposals, they should also contribute to spreading excellence across Europe, for example, through the involvement of widening countries. I think this was the strongest formulation the Commission could find that wouldn't get into some legal challenges of discrimination, etc. And I insist this was unique in the many, many calls of the Horizon Europe program. Only the quantum calls had this. So in some sense, there's a special effort here in the quantum flagship that I hope, if successful, can be reproduced by other programs in other areas. And we still don't have results from these calls to measure how successful this is or not, and how inclusive the winning consortia are, and the member states, how many and how much they are involved in this European effort. And finally, I just want to emphasize that you may know, of course, that there's this other special programs in the EU, the widening and teaming programs, and that this initiative and this sentence that we added and managed to add with the help of the Commission, or the Commission accepted to add it, is independent from that. So this is on top of those general EU programs to promote the involvement of widening countries. We were able to do something specific for the Quantum Flagship. So now some questions for discussion, maybe today, maybe for reflection in the future. And if you're interested in discussing these issues, do engage with us at the Quantum Community Network. So the first is, do widening countries really have the goal to escape their widening status? Okay, so maybe this is a bit provocative. So this is a personal question. I don't want to blame anyone else for this question, but my impression is that, you know, there's this danger that countries want to benefit from some programs, let's call them advantages, which I think are fully justified, by the way, of having this widening status. And I think this can be a vicious circle. So I think these widening measures to promote the participation of widening countries in the European Commission programs are very important. So we fully support them. In fact, we went beyond that, as I just described. But in my perspective, this is a personal opinion, it's not reflecting our work group effort in the Quantum Community Network. In my personal opinion, I think our goal, this is at least how I see it, is really to escape the widening status, to reach a level of scientific performance and innovation in our countries that we can, this should be, we can escape this status. Of course, this goes much beyond the particular topic of quantum science and technology, because this is general scientific and innovation performance. But at least I wanted to convey this opinion or this spirit that, you know, widening is the widening solutions, the solutions to promote the participation of widening countries. They should be a stepping stone to you know, resolving this imbalance in performance in Europe. The second is, did these solutions work? So we're waiting for the results, the official results, so that we have information, we can do a similar study as we did for the ramp-up phase. So we don't know yet. Let's see. I'm very, very curious, as I think many colleagues are. If they did work, or whatever worked, I think is excellent, that you can also disseminate these to other domains of science, to other areas of the Commission and member states and their organizations, and see if any of what we did, which worked, could be copied in other domains. Also, and this is just my ignorance, maybe there is great data that I'm just not aware about, are these more general programs on for widening and teaming in the European Union, how well are they performing? And in particular, what is out there in terms of quantum technologies, quantum science and technology in these programs? We actually have not been able to collect data yet. So there's still things to be understood and to be learned. And so let me jump to my conclusions. So the first, I want to emphasize that the poor involvement of widening countries in flagship projects, it's a European problem. It's not only a problem of the widening countries. It's a cohesion and sustainability challenge for the whole of Europe, and in particular of the European program in quantum technologies. So all countries should be engaged in finding the solutions. The second point is that I think this is a vicious circle that needs to be broken, right? I think this probably is very clear. So there's this famous result from network science, you know, rich get richer, and so of course this also happens here. So it's very important to find these measures and see if they work, and if not, what else we can do to break this vicious circle. And also there's, as I mentioned, there's good, very nice results from the latest Quantera call, and in general the Quantera calls have been promoting the participation of widening countries with much success, in particular in the latest case. But I think we shouldn't, this is great, but this is not enough, and certainly this should not be accepted as an excuse. I'm not saying anyone presented this argument, but should anyone present the argument saying, oh, you know, widening countries already get a lot, do well in the Quantera calls, why worry about the flagship? Well, I think this is certainly not enough, and just because of the first point of sustainability and cohesion and fairness and exploiting all the excellence in Europe. The third point is that, you know, how to break this circle and what other measures can we do? So can we develop? So it's very important that I think this is a pretty obvious statement, but let me make it. It's very important that research and organizations from widening countries are empowered, and that they network, they are included obviously in consortia, but even in initiatives like even conferences, etc. So because I truly believe there's great excellence in all these countries that often is simply not known. Let's be honest, there's some prejudice within Europe between different countries, etc. And this percolates also to science. That's unfortunately the reality. And we should break this vicious circle and this image. And it's a matter of giving more exposure, more networking. And I think what you're doing here is great. So this Quantum Eastern Europe conference is very, very important initiative. I want to insist on that. And maybe one challenge for the future is why not promote it so that you have a non-Eastern European audience to expose all the excellence that you were able to expose in these couple of days. So this could be one way, but there's other things we should do. And in fact, the new coordination and support action of the Quantum Flagship that Tommaso mentioned will also try to address this. And if you have suggestions, if you want to contribute, do reach out. We would appreciate this a lot. And I think, we need a lot of, anything that can be done in this front will never be enough. Finally, I want to tell you about what we're now starting to call Euroquantum, which is a vision for what could become the flagship in the future. And essentially, the key idea now, but this is still in early stages and in brainstorming, is to, as you know, there are some initiatives on quantum technologies in different countries. We just heard about a pioneering one in Hungary. And we want to network these national quantum initiatives and increasingly give it more prominence, more robustness to potentially take over as the future of the development of quantum technologies in Europe in partnership with the Commission. And so it's very important to create these national initiatives. And of course, this is not easy. I talk with my own example in Portugal, where we've been trying for a bunch of years without much success. So I appreciate how hard it can be. But it's great to have some countries that are very advanced in this front and that we start all networking with them. And I think the Commission also sees this as very important. In fact, there was a meeting last week of the Strategic Advisory Board of the Quantum Flagship program, where there was a very strong endorsement to try and have countries have their own national initiatives, and that this is networked. And we have, synergies and win-win solutions. So even if there is no national initiative or some sort of program in your country, be certain that, we as the Quantum Community Network and Quantum Support Action and in general community do reach out. We try our best to in this network approach to support you, and because there's this also sort of top-down endorsement that will become public at some point, then you can also leverage this in your government to make sure your country is not excluded from whatever future network, European network, will emerge in this front, and also with the encouragement from the Commission and its Strategic Advisory Board for quantum technologies. Besides this, which is, early steps, but no reason not to try and join already, there's, of course, these very important deployment programs that Tommaso and Edina already alluded to. So the European Quantum Communication Infrastructure, which is more advanced, and the European Quantum Computation and Simulation, which, as was clearly presented, is the idea to start deploying quantum processors or co-processors in high-performance computing centers across Europe. And so this is more an infrastructure program than a research program, which is great. It shows that quantum science and technology is evolving in different fronts, and in particular the quantum communication infrastructure, because it's a sovereignty issue, and quantum technologies are sovereignty technologies. We should never forget that, because this is a very important and honest argument to used when we approach our governments to develop such initiatives, national initiatives and programs in our countries. This, I think, although these are infrastructure initiatives. And the second one, computation, is maybe not as widespread because it builds upon existing advanced computing centers, but the European quantum communication infrastructure is really wants to cover every country, and so this can be a good reason, a good excuse to start developing also the research and also the innovation around this infrastructure, and this is by definition a network. So you can also leverage the initiatives in your neighboring countries and try to explore these cross-border links and to be more and more connected to what is happening in Europe at this level. So all these initiatives taking place, I think, are a great way to involve more and more widening countries, all countries, but in particular widening countries in this domain. And finally, besides these programs, just projects in general, that even if they're not about research or innovation or deployment and infrastructure, there's a lot to be done in terms of the coordination of the efforts in Europe in this domain, and hence this new coordination and support action, where there was an effort to involve more widening countries, which was successful to some extent, and I hope in the future this will increase. But also initiatives and networks for education and for outreach. All of this is a good start. All this is helpful. Is always a way to be more, to get more exposure to what is happening in your country, in your organization, in your research group, to other people around Europe, and to get to be more networked, and so that you are considered for future consortia. And in particular, these new type of initiatives in the Quantum Flagship, the framework partnership agreements, which we may discuss a bit later, to see if there's any chance to get involved in the future or not. And so this is essentially what I wanted to say. Oh, I also wanted to mention the World Quantum Day, which is a global initiative with colleagues from more than 65 countries. It was chosen that 14th of April is the World Quantum Day, and it's sort of successful. If you go to, it's a bottom-up initiative, but if you go to Google and type World Quantum Day, Google says 14th of April, so I think that makes it official. This is essentially a bottom-up outreach initiative. We had a pre-launch a year ago, and we had the first celebration this year on April 14th. It was it exceeded all our expectations. We had many events. So more than 44 countries, more than 123 cities, more than 17 languages. This is a conservative estimate. I think that there was more. And this, I'm saying this for two reasons. First, to advertise in case you didn't know, and if you wanted to get involved, we have pretty good coverage of Europe, although not so much in Eastern Europe, and in particular in the Balkans area. So if you want to get involved, do get in touch. But just also to tell you, this is yet another way to be in touch with other colleagues, in this case in Europe, but also beyond Europe. And interesting collaboration and opportunities may arise from there. So this is also something that can be a start of more involvement. And this is it. I want to thank my research group just in general, although here is not particularly relevant, and just repeat my conclusions. Thank you very much.
Thank you very much, Yasser, for the nice summary. At this point, I recommend that we move to the panel discussion part. So I'm asking all of you to switch on your webcam so that we can talk. And also I'm asking to try to, we have 30 minutes now, or maybe 25. So let's try to keep the answers short, below 2 minutes. Yeah, so it was very nice to have these specifications about the EU level initiatives and topics about widening countries. Let me go back to the sort of global direction. So my question, and this is addressed first to Tommaso, I think, has the EU defined very specific goals in the global race in exploiting quantum technologies? So like in a 5-year or 10-year timeline, is there a specific target like hitting 50 qubits with superconductors or something like this? Boxes you can tick when you've done that? Tommaso?
So yes, there are. So this is these are what we call KPIs, the key performance indicators for the flagship. And some of these are public, such as we want by the end of the Horizon Europe program for Europe to be among the 2 strongest economies for quantum technologies worldwide. And some more technical ones, such as how many qubits do we target for a certain platform and so on. We have prepared them. They are being discussed and used by the Commission also for internal evaluation. But since they have been prepared also with input from industry and from the consortia, and this is very competitive, a lot of these key performance indicators may contain indications on, information which some of our actors and companies do not want to disclose to outside extra-European competitors. So yes, these numbers exist, and we can discuss among colleagues, of course, but it is something which we have been asked not to discuss publicly, because indeed those start being some very sensitive issues.
Thank you. If you allow for a naive reaction, this is a very ambitious goal to be in the 2 strongest economies, quantum technology economy. Is that correct? That's
yes.
Yeah. So China, is US, and Canada. These are great competitors, I believe. So that's,
it is indeed very ambitious. Yeah, and it is to be understood as the goal. So it's not like if it doesn't happen at the end of Horizon Europe, then the flagship will have been a failure. That's not the point. The point is really the target. What we are working for is this level of ambition, because we do not want to be back at the back of the pack, as it happened in other cases and with other technologies. That's certainly a common willingness.
And the time scale is then like 5-6 years, right? End of Horizon Europe.
Precisely 5 years, I could say. Yeah.
Thank you. Yasser, are there any KPIs also on the level of like widening countries, maybe?
No, actually they're not. That's maybe something we should have considered. To the best of my knowledge, we don't. But we do monitor this, as I mentioned. So we are waiting for the official results. Yeah, maybe this is something to consider. I honestly had never thought about it. This is something to consider and to propose. Maybe this is the way to go. As Tommaso was saying, one defines such ambitions, and then this immediately makes it easier to find support and organize things to address them. If I'm also allowed a comment about the previous point, I think being at least in the top 2 is actually feasible. And colleagues from North America and from Asia, and including China, they see Europe as a powerhouse. So yet another reason for us to leverage all the competence, all the expertise and excellence that we have around the whole of Europe.
Thank you. Edina, on a national level in Hungary, can you sense some very specific goals, targets to reach? Please unmute yourself, please. Yeah.
So in terms of KPIs, certainly the projects themselves set these KPIs. In terms of involvement in the European initiatives, as a governmental body, it is our expectation to, when we invest in significant national programs, that we see a comparable rise in the activity at the international level as well. And so far, we've seen quite a good level of activity of our researchers in the international programs. And basically, our aim is to keep that level up, because that's why we are making those investments.
Okay, so these are not specific technical KPIs, but more like acquiring funding from the European level, besides the Hungarian funding. Funding
and involvement in general.
Yeah, thank you. Related question is about the relation between the EU and the other countries in the global race. So maybe this is a question addressed to Tommaso. So what is the relation between the EU and competing countries like US, China, Canada? Is it considered like a collaboration or a competition? how much information is hidden in the dark, how much information is exchanged, or does the EU encourage EU researchers to share information or to not share information? So what's the strategy of the EU in this global race?
So there are a few important aspects here. One is that in the center of the EU's concern is the fact that the ideas that we develop and we fund in Europe lead to creating value in Europe. Unlike the internet, which was invented at CERN and led to enormous profits completely outside of Europe. That's the guiding principle. So, proper protection of intellectual property and proper agreements for cooperation in trade contexts is a very, very prominent aspect here. The situation is evolving because first, a couple of years ago, I have been asked by Commissioner Gabriel to, with the US in particular, because the US are being considered as, compared, for instance, to China, as having a different level of standards in respect of intellectual property right, international law. So she asked me to start a discussion on the basic science level. So I had a few meetings, a few trips to the White House. We also had a workshop with the international cooperation coordination action that we have here in Europe. And this led to establishing a set of topics, which could be for some joint calls. Then, with the change of administration, this has not been pursued further. And now we are at the stage in which there is a Trade and Technology Council, TTC, a very high-level dialogue for technology and trade, indeed, at the level of 2 European Commission vice presidents and Secretary of State and Secretary of Commerce from the US government, which are meeting actually next week for the second time for different topics, including microelectronics, chips, and other things. And one aspect that which we are starting to discuss is that maybe by the next meeting in October, a working group on quantum technologies could be established in such a way that we can, develop a joint agreement and a joint strategy for that, taking into account everybody's interests. So it is a very delicate topic. Also, it concerns aspects such as export control, in which we have learned through colleagues in other member states that there have been, because those are discussions which happen confidentially, but we learned through Scandinavian colleagues somehow that some limits to export, some control of export for computers above 200 qubits were being considered, and we released a document jointly between the quantum community and the Quantum Industry Consortium, saying that no, you need not only to specify a number of qubits, but it has to be also some errors and some proper benchmarks. So it is really a very hot topic of discussion, this aspect of how much we can cooperate. The general intention is fair cooperation, but also paying attention that value is created and industrialization takes place also here in Europe.
Thank you. So I would address my next question to Yasser about widening country issues. So actually, I asked about this also Edina after her talk. So in the previous session, there was a meeting between leading researchers of the V4 countries, Visegrad 4 countries. So that's Poland, Czech Republic, Slovakia, and Hungary. And it seemed that there is a strong incentive or internal drive to try to formulate some kind of joint collaboration between these countries in quantum science and technologies. So do you think the EU has funding tools to help that? So are there tools available for collaborations of widening countries, for example?
So maybe Edina knows more about the mechanisms besides the flagship. So I'm more familiar with the flagship specific mechanisms, with the flagship, which are essentially calls. But what I would say, this is definitely a very nice initiative, and it helps always to have something that involves more than one member state, and in particular at least 3 member states, to get support from the Commission. So I think this can only be good. And you should also consider, how this can integrate a wider network in Europe without, of course, compromising the collaboration between these 4 countries. If that's the goal, that's great. But this can also contribute to a wider networking in Europe. So I think there would only be moral support. Now, financial mechanisms for that, I'm unfortunately not familiar with other programs besides the Flagship. I don't know if Edina or someone else would be familiar with that.
Yeah, so maybe Edina, so I can even make this more specific. So there was an Excellence Hubs call, which I think was closed a few months ago. And I think this was targeting widening countries. So it looked like an ideal tool for this purpose. And maybe one question is, will this be repeated in the future? Should we expect that there's going to be other versions of the same tool coming up?
Well, the Horizon Europe does have, not a very large budget, but a budget specifically dedicated to these widening type instruments. So certainly that's one way to go, but there are also other funds beyond Horizon Europe that could be considered. So I think there needs to be a proper dialogue between our countries in this respect to see what the most suitable tool is to fund such collaboration between V4 countries. Certainly it's something that would not make sense in isolation, but bringing visibility to what is being done in this respect and aligning with the Flagship's strategic initiatives to make sure we're heading in the same direction.
Mm-hmm. Thanks. And next question is maybe also addressed to Edina. Can you briefly describe what is the relation between EU funding and Eastern European non-EU member states? So is any funding tool available for non-EU members? Because I mean, this conference is focusing not only on the EU part of Eastern Europe, but also broader. Mm-hmm. That's why I'm asking.
Yes, I think it depends country by country, because a lot of countries are either already associated to Horizon Europe or in the process of being associated. And in principle, Horizon Europe is open to the world. So if a country is not yet associated, a country itself can provide funding for their researchers to participate. If they're already associated, that means that there are already funds dedicated for their participation. So it's really a process that's at the beginning of a 7-year funding framework. It's evolving day by day. So there are reference documents that give specific guidance on specific countries on how to get involved and what funding is available and at what specific point in time.
Mm-hmm. Thank you. So let me shift gears and talk about a very specific funding tool within the EU in quantum technologies, and that's the Framework Partnership Agreements. So my understanding is that, again, a few months ago, there was a deadline where for the different topics, there was a call for formulating these Framework Partnership Agreements. And so the proposals has been submitted already. And my question is, will the resources of the successful FPA proposals be available for researchers or enterprises that were not part of the proposal? So this is, I think, a FPA is like a long-term plan. So you apply now, and then that's a framework for like 7 or even more years. The question is, are these closed structures, where the resources are available only for those who were there initially, or it's going to be sort of opened up to a broader set of people and organizations? Tommaso?
Yes, so indeed, this framework partnership agreement call is a funny one because you write a big proposal and then you get zero money. So in fact, the consortium, the consortium in each call, which will be selected, will be approved not for funding immediately, but for, let's say, this authority of proposing further so-called SGAs, specific grant agreements, which is where the money actually will flow. And these SGAs, of course, they will be based on the people who have applied for the FPA, because hopefully they are the biggest experts. But at the same time, they will be open to, involving other partners, the best that there is. And partially this will be evaluated by the Commission. Partially there will be a certain, let's say, degree of trust. So the consortia which will have been approved to run this framework partnership agreement, it means a kind of validation that the Commission says, okay, these are good enough people who can sort of manage, who can handle this. But indeed, it is both the intention of the consortia, which I am aware, and certainly of the Flagship altogether, as well as of the Commission, that this is not just a closed situation in which only those who have applied will get the funding, but there are, and this is also the reason, for instance, there are possibilities for changing the consortia and updating them. That is the reason why we have not just one long grant, but two specific grant agreements, the first and the second part, which allows for further updating of the consortia. So there will be two additional points in time. One is the application of the first SGA, and then the application for the second SGA, in which it will be an opportunity for other partners to come on board.
Mm-hmm. But it's mostly based on the judgment of the already existing consortium, whether they can enter or not, and that's not going to be another like peer review step in
it is based also on the judgment by the Commission, so it is a joint judgment. Mm-hmm. It is not just by the Commission and peer review, like if you start from scratch. Mm-hmm. It is the Commission which says, okay, here is a consortium which we know they have been validated by peer review, that they can do a good job. And so the Commission will take proposals. They will not take for the SGA any proposal, but they will take proposals which come from those consortia. On the other hand, there is a very strong awareness, that this process is for the whole community in a sense. So there is a very strong awareness also in the consortium, which I am aware of, most of those which have been applied for, that this has to be done according to some high standards. And so the consortia, I know they have set up already at the stage of consortium forming some form of, kind of application procedure or declaration of interest, and then some form of filtering using, for the possible partners, using some very authoritative colleagues. Maybe, we have some of the protagonists of this field, which now they are no longer so active because maybe they are retired, and they have been asked to sort of look into this and give some sort of high-level validation in a form. It's not peer review in the standard formal way, okay? But, there are different kinds of processes which are being put in place in order to get the best possible result. Mm-hmm. And in any case, the peer review is taking place at the level of the FPA, and I believe also at the level of when SGAs are submitted. So the Commission is not just blindly taking whatever the consortium is saying, but is sort of, participating actively in the decision.
Right. Thanks. And another question about FPAs. So what is the vision targeted by the FPA programs? So is it expected that these FPAs will make the EU competitive with US tech giants or the focused and centralized Chinese research policy? Is that the vision or the goal?
Yes. Well, we should say that in some of the fields, we already are competitive with those US tech giants or with US companies. For instance, the field of neutral atom quantum simulation, as well as the field of ion trap quantum computing, are fields in which we are really, one could say, on par with the US. On the other hand, as well as the field, for instance, of NV Center-based sensing, we are definitely ahead. Yeah, and also in quantum communication, the world's market leader is sitting in Switzerland, and also other, which is not EU member, but it is in Europe, and a lot of the startups are very competitive there.
Quantum Internet, I would add.
That's right. That's correct. Yeah, absolutely. Now, one very prominent example, though, in which US tech giants are ahead is superconducting quantum qubits for quantum computers, superconducting quantum computing, in which our project has still, I would say, between 1 and 2 years delay with respect to the development there in the US. But I would like to remind that this is one specific platform of one specific application area. And so I would say that, as a matter of fact, in most application areas, we are actually on par or ahead of the US. China is still catching up in a lot of respects. They are very strong. They are having a huge investment, but there are a couple fields in which they are ahead. For instance, they had this very remarkable demonstration of quantum supremacy with photonic qubits. Okay, again building on ideas which had been developed in Europe, but still, with a very substantial implementation. But it's not a general fact, and this is what corresponds to the ambition that we discussed before, that Europe be at the end of Horizon Europe in 5 years among the 2 world's strongest quantum economies.
Mm-hmm. Thank you. And now switching to our last topic, we have still 5 minutes. And this, maybe we could start from the national level. So is it a goal in the EU level or national level to transform researchers to innovators or entrepreneurs? So what about Hungary? Is there a drive towards the direction?
Yes, I think this is a trend that we have seen in both national and EU level programs, that we recognize that Europe is probably the weakest at transforming research results into industrial opportunities, industrial values. So this is a trend that has led to Horizon Europe itself, but also many national programs emphasizing more the academia-industry collaboration, emphasizing more the establishment of startups that take research results further and faster. So it's certainly in the case in Hungary that this has received more emphasis in the last decade or so.
Yeah, let me turn to Yasser next, because as far as I understand, you do have some personal experience also in that. So I think you have founded a company yourself. Do you have any recommendations or best practices on how to get started, how to balance between different roles of being a researcher, administrator, technology, business?
I'm not sure I'm the best example. So I'm theoretical physicist, do stuff more on fundamental level, typically, although not only. And indeed, I did start with a couple of colleagues a startup, but for consulting. So it's not really a technological company in the sense of developing a new product, a new technology. Is more in terms of raising awareness and giving advice and maybe setting up some applied projects. I think it's going well. It's not my main focus, let me be honest. So I invited other colleagues who have more that entrepreneurial spirit that I lack, and I'm more focused on research. But what I find interesting is that there could be interesting research problems applied, or sometimes even motivate more fundamental challenges that come from this interaction with industry. So my experience is very limited, both because this is recent and it's not really my profile, to be honest, but I find it interesting. The only advice I could give, I don't think I can give many advices on this for the reasons I explained, but one advice I would give or perspective is the following. I think at this stage, the most valuable asset in this field is knowledge, is expertise. Okay, there is more money, I don't know for how long, but there is more money to hire expertise than expertise to be hired. By the way, this now means there's a strong and increasing effort that is happening on training on quantum science and technology, which all our countries should explore, and also in a networking way across Europe. So maybe then in the future, there will be many, many people with this expertise, and this situation will change. But if you have expertise in this field, you should be confident that this is a great asset, even if you're in a country where there is no national program like Portugal, or your university doesn't really think this is an exciting field or whatever. If you have expertise, then this is something you should explore, because it's the most valuable asset that we have, I think, nowadays, and you should be very confident about it. So this would be my perspective.
Thank you. So we are running short on time, so that brings us to the end of the discussion. I would suggest that we use the last minute to make some final remarks. So if you have some message you want to share with the conference audience, please let me know. So Edina, maybe a final remark or some words.
Yes, certainly in the Hungarian experience, it's been a very valuable approach to move away from open programs to targeted thematic programs, because it really puts the highlight in upcoming hot research fields, and it gives the opportunity to researchers to come together, work together, consolidate their knowledge, and be more visible internationally as well. So I would certainly recommend it in other countries as well.
Thanks a lot. Yasser, some closing remarks?
Yeah, I mean, my remarks would be network. Let us know how we can help in any front. Congratulations on this initiative. I love your logo and all the colors of the flags. It looks beautiful. I'm a bit sad that it looks like the continent is separating around France. There's this famous novel by the Portuguese author José Saramago, The Stone Raft, where he imagines a novel where the Iberian Peninsula sort of detaches from Europe and flows away in the ocean. If you like literature, I recommend it. But I was a bit sad to see this gap there. So I really honestly congratulate you on this initiative of focusing on raising awareness in this part of Europe and being very comprehensive north to south, but don't decouple from the rest of Europe. I think this is in everybody's advantages, east, west, north, and south. And there's all these ongoing initiatives that we try to convey. Let us know if we can help in any way developing this domain in your country, organization, group, etc.
Thanks a lot. Tommaso?
So for me, the central question, as Edina knows, because we have discussed very passionately about this in the Quantera meeting, is the same that has been asked to me by Commissioner Oettinger. The first time I showed him quantum technologies and I asked for the first billion, and he said, you need to show me the pan-European dimension of that. So this is something we rise and we fall together. I know that not everybody understands this. I know that sometimes I have to sort of very strongly make a stance on this, also, towards my colleagues in Western Europe, but we still rise or fall all together. And the more we realize that, the more we will be successful. And this is why I think that this initiative is important, not to build a rift, which is not the intention, but to build a strong common basis. And we have to go a long way to do that, and count on the fact that we will do our best.
Thank you very much for this encouragement, and also thanks to all of you for your contribution, helping Quantum Eastern Europe with your talks and this discussion. So this concludes this session, and I think we will reconvene in 12 minutes with an end users panel discussion. Goodbye.
Thank you very much for organizing this, and congratulations.
Thank you.
Thanks a lot.
Bye.
Thank you.
Goodbye.